So we've talked about testing, talked about test-driven development. We've seen Jest, and we've seen Python's unit test library. And you may have had the question kind of like, well, how do you know that you've written enough tests? Or how do you know, of course you can do a few tests, but it's hard to tell exactly when it's good enough or how you can even know that for sure. So we're going to look at one tool that can give you some insight. It won't solve all of those, won't answer all of those questions, but so it's something called Coverage, and it's also a third-party library. So it's a third-party library, so we're going to have to install that. So we'll talk about how you do that. But Coverage is a third-party package that basically will keep track of what lines in your code executed. So if you're running testing, you can check if your tests are hitting every single line in your code. So this is useful for, does this function get called? And I think maybe even more useful for especially deeply embedded conditionals where you may be writing some tests and you're just testing the final result, but not every path in your code is being traversed by your tests. Okay, but before we actually start using a third-party module, we're gonna need to install it. But we don't want to just install things globally on our machine. If you just do it with a couple of packages, it's fine. But the more you do, the more likely you're going to get conflicts, and all kinds of problems can emerge. So I'm going to share my screen. So the first thing we're going to talk about. So here's the application we'll be using, but we'll kind of put that on hold for now. So what we want to do is create something called a virtual environment. And this is basically a disposable, self-contained environment that is applicable only to your project. So if does this concept sound familiar to anyone?
Virtual machines.
Okay. Virtual machines. Yeah, so it creates kind of an isolated environment.
It's kind of like the same concept as scope, but for like packages, right?
Yeah, so you're creating kind of a new scope, right? So yeah, so that is part of it. So what about node projects? So how do we make sure?
NPM.
Yeah, so we use npm. So if we want to create a node project, right, we have to create we run npm init, and that creates a package.json file. And then when we install packages, it's gonna create a node modules folder, and it's gonna download and install those packages. But those packages can only be used in that specific local environment that you're in, right? So it's not installing globally on your system. If you change directories and work on another node project, you won't have access to those packages, right? So you create a self-contained project it's only got what you need for the specific project that you're working on. So you can do something similar in Python, which is to use a virtual environment. So here is the documentation. So VENV, short for surprise, surprise, virtual environment. This is in the standard library. And the way we use it is a little different than the way we've used other modules. So we're actually going to run it from the command line. So it's not something that you're typically going to be, create a file, import venv, and then run some methods in venv. So we'll be seeing this repeatedly. So I'm just kind of introducing the idea right now. But the way this works is you run Python -m. So this flag indicates that you want to run a module as a script. So we're going to run this module. Right. So Python, and then we're telling Python, hey, this is a module, but I want you to just kind of run it directly. And then the module is going to be venv. And we need to pass it one more argument, which is going to be the name of the folder. This can be any name that we want, but this is going to be the name of the folder where we want to keep all of our stuff, just like the node modules folder. So we can call it my venv. So you run this, it should take a second. Notice up here, we've got a new folder. So just like when you run, npm init or you install stuff, there's a lot of things happening under the hood, but ultimately you're going to get some kind of new files, or git init is the same way. So you don't really need to worry. Again, you don't need to like go in here and fiddle with stuff. I would say, I'm sure there's a use case, but basically you don't need to worry about it. So here are some executables. Use Python 3. Again, you don't need to worry about that. The library, it doesn't have much in it now, but once we start importing third-party modules, this is where they're going to go in here. Just like node modules. Okay, so we have this virtual, actually, let me, so just pretend that that wasn't there. So we have this virtual environment, and it's here, it's in our, it's at the root of our project. But if we went and did pip install whatever, this is just going to install globally. It's not actually going to be diverted into our virtual environment. So in order for that to happen, we have to create it first, which is Python -m venv, and then whatever you want to call it. And then you need to activate it. So the way you do that is source. And then there's actually a script in here, right here. So this is a bash script. And we're going to need to run this script, and then everything else will be taken care of. So source. So source my venv. So we're gonna have to give it a path to this script file here. So my venv /bin/ activate. So if we run this script, notice this change here. So if you set up your bash profile properly, this should show up here. So this indicates that you're now in a virtual environment. So if I want to start installing stuff, third-party packages, it's not going to install globally on my machine. It's going to install here, only inside my project. So that's basically it. So now at this point, we would install, and then in our project, we could import stuff and use it. So what do we want to install? Well, in our case, we want to install this coverage.py. This is a third-party module. You can see it's a tool for measuring code coverage of Python programs. So let's install this. There's in the README, it tells us here, pip install coverage. And it'll take a second. And this is a pretty small package, so that was quick. Other packages may take longer, and there'll be multiple dependencies. But now if we go here into the virtual environment and look at in the library, you can see coverage. So coverage is here, and it's got all the code. Just like node modules, it's got the actual code here. So if you wanted to look at it or modify it. Not that that should be something that you would do seriously, but you could if you wanted to do that. Okay, so now we've got this third party, we've got all this third party code loaded up in our project, so that means that we can start using it. So before we start actually trying to use this, let's take a look at our code here. So this is code for, so this is code that kind of represents the interaction between a mechanic and a car. Is this large enough, by the way? Am I zoomed in enough? Okay. So we have this mechanic class and we have a car class. So the car class is going to be initialized. You're gonna have to pass it a brand. So we'll have a brand. And then when you first create a car instance, it's not gonna have any defects, right? So the defect property will be none. But it will run wear and tear. So this is a very simple implementation, but so wear and tear is going to return, you basically have a 50-50 chance of getting a 0 or a 1. And then we have another method here called take damage, and it's going to call self dot wear and tear. Actually, I probably don't need to call this here. Let me comment that out. It's going to call self dot wear and tear. And then this is just hard coded. Again, this is not, this is just here to get us moving. So here are some possible defects that a car could have. And then a random defect will be selected if, you know, if this is 1, if this evaluates to true. Otherwise, basically nothing will happen. Does that make sense? Anyone have any questions about that? Okay, so basically you have a car and then there's some chance that something will go wrong with it. Then we have a mechanic. So a mechanic will have, let's say, specialties. So mechanic will be able to fix certain problems. And mechanic will also accept a car to work on. And then you can try, the mechanic can try to repair the car. So it'll check if the current car's defects is in his specialties. So if he's able to fix the car. If he's able to fix the car, then he fixes it. So he changes the defect property of the car to none, right? Otherwise, you get a message printed. And then here, this is a get estimate. So it's just, again, going to check if the defect is in the specialties. And then this is just arbitrary, just to get some if statements. But if the brand is a Ford, he's going to charge $500. Otherwise, it'll be $300. And if he can't fix it, then the estimate is going to be 0. Are there any questions about that? So just some, you know, kind of silly code to get us started. All right, so let's focus on writing tests. So let's start with Anthony. Did you just drop off? That's fine. So let's start with John. So help me, so I want to write some tests for the car.
Right. So the first thing you'd want to do is import unit tests, test case and main.
Okay. Okay. All right, so you got the boilerplate out of the way.
All right. So then I guess you could do like a def test, car creation, and just start by creating a car and see if it has the brand and defect properties.
Okay.
So car one equals or self dot car one.
Is it self.car one?
I guess no, it doesn't have to be. So you do car parentheses. Then next line, or yeah, you'd want to pass in brand. So whatever kind of brand.
Okay.
Yeah, and then Chris mentioned you got to import car as well. Oh, yep. Car.
All right.
All right. So then you can do self dot assert equals or equal. Car one. Dot brand, comma Mazda. And then next line, self dot assert equal defect, car one or car one dot defect should equal none.
Okay. So I could do assert equal, and that's fine. I could also maybe do assert is none.
Oh, yep.
All right, so let's run these tests. Okay, so they pass. So that's good. Let's see. Jen, can you help me write another test for car?
Okay, so we can test the take damage function. So def test take damage and pass in self. Now let's do car one again, sure. And okay, so let's run take damage. This would be car one dot take damage, and with the parentheses. I don't think we need to pass anything into that though.
Right.
And that should run wear and tear, so we can see. I don't know if we can test if wear and tear runs. How can we do that?
That's a good question. So are there any other problems? Is anyone seeing any potential problems here?
We're not testing wear and tear first.
Okay, so we're not testing wear and tear. So it might be good to test wear and tear first.
Okay.
But even if we did test wear and tear first, so we were sure that it worked.
It returns a random. Oh, go ahead.
Yeah, I was going to say the same thing. Since there's a random, I'm not sure how we would work that into the test.
Maybe we could set a seed and then test it with the seed.
Okay, we could set a seed.
Well,
But
when we
yeah,
I
go
guess
ahead.
the pass, we'd have to patch wear and tear. So when the wear and tear method is called, it receives the response or the return value from the patch, not the random range.
Yeah. So one thing that we want to make sure we're doing with when we run tests is that it's always the same, right? So we want everything to be the same every time. So if we're making, for example, an API call to some other server or querying a database, that's a no-no. We don't want to do that because now our tests are dependent on other things in the world. So we want to make all these tests independent. So that stuff includes not just, you know, API calls and things like that, but also things that are unpredictable or have, you know, impure functions like random. So we should use a patch here. But I think we can get away with just patching random range.
Is this a case where we would we would need to use a method that's more sort of looking for based on it dependency injection for take damage, where we pass in the result of wear and tear?
We could do that. So we could definitely change our code here and pass in a function that we want to call, right? Maybe we could pass in something like this function. So we could definitely do that. We could definitely do dependency injection. But let's just say so, and that is one alternative. Another alternative is to not change any of our code directly, but to simply make rand range return something predictable. So Cindy mentioned seeding. So that's something that you can that you can do when you're testing to get, you know, it's random, but it's the same random thing every time. The issue is that we can't necessarily directly do that because we're calling rand range here. So if we add a seed, that's going to affect our production code, and our production code isn't really going to be random anymore. So you basically need to fake rand range. So we can do that with a patch. So we can use a patch to do that. So let's try.
We may want to take off line 13.
Okay. Yeah. So we'll comment these out for now. We can delete them. So we'll do with. And I'm going to need to import patch. So from unit test mock import patch. So patch, what I'm going to pass in here is basically the import. So the kind of import path to whatever I'm using here. So since I'm in, I only want to change it for this particular file. So I'm going to pass in car. So I'm going to grab car.ranrange. And I'm basically going to interfere. I'm going to replace it with something. So I'm going to call this fake range. And now that I have this fake random range, which actually it's not doing anything right now, right? I need to tell it to return the same thing every time. So I'm going to do fake rand range. And then there's a whole bunch of properties and stuff. One of them is return value. So I can set that equal to whatever I want. So let's just say 0. So now when the unit test runs this file, anytime we have car.randrange, this fake thing that comes with unit test is going to get called, and it's going to return 0. So this is always going to return 0. So then once we have this, let's create an instance. So car, use this.
Chad, do you mean to put wear and tear instead? Because rand range isn't part of a method of your class. That's a return. Yeah, that's a return value call. I mean, on line 13, sorry, patch. Your patch in the quotes right there. It says car.rand range,
Yeah,
but rand range is not an attribute of the class.
yeah, but right, it's not an attribute of the class, but it is located here. So it should work.
Okay.
We can try it. So it's
Yeah.
you're right that it's not like, car doesn't really own rand range. Might be able to do something like maybe not main, but yeah. So we'll try this and see if it works. So car one is we create a car and then let's call so let's do an assert
So,
equal.
Does this patch only actually happen for anything within the with command?
Yeah. So we're creating a context. So just like we saw with files, right? So just like with files, you can create a special context, the context manager, and then perform some operation. And there are two methods that will get called. So this patch, we know for sure if it works with the with statement that it has an enter and an exit thunder implemented. So I don't know exactly what they do, but they exist. So when this runs, this will be created, and when it exits, once this with statement is over, something else will be executed, and some kind of cleanup will be run here. Self.assert equal, and we'll do car1 wear and tear, and that should equal 0. And further, we can also test if this was called. So one of the other benefits of these mock, or these mock objects, which patch is one variety, they allow you to do a lot more things rather than just seeing, changing a return value or property. You can actually do fake range asserts called once, for example. So we can actually check if this was called. So let's try running this. And these tests pass. So the question, I know that this patching and mocking is kind of a weird concept. We've seen it before, but it's a bit strange.
Can you say for line 17 again what that's doing?
Yeah. So again, there's a whole bunch of things built into this mock object, and we can look. So if you look at the documentation, there's a whole bunch of things, magic mock, there's mock objects. They're all basically the same, just like slightly different flavors, but there's patch, which is what we're using. You can implement it as a decorator or as a context manager or whatever. But it's basically going to create a mock object, which has all these funny properties that allow it to be extremely flexible. So one of the things that you can do with a mock object is you can do assert called once. So there's a whole bunch of other things. You can check what parameters it was called with. So we can check called with, where is that? Called once with, and let's do, I don't know if this, let's see if this works. And just to make sure you get a failing test, if it's wrong. Right, so that fails. So there's all kinds of just these little things you can get finer grained insight into what your code is doing. Okay, so that's test wear and tear. So I think let's go ahead and just see where we're at right now. So if we're writing unit tests, we might think, okay, this is pretty good. Maybe we write one more for take damage. Actually, let's go ahead and, well, whatever. Let's run coverage now. So if we kind of want to know, like, are we done? Are we done writing unit tests? And there's a lot of different ways you might want to figure that out. But again, one tool would be test coverage. So we can see if the tests that we've written are executing or exercising all parts of our code. So the documentation for coverage is here. It's pretty good. But again, this is going to be something that we use on the command line, like then. So we're going to do coverage. So there are a few steps involved here. And again, don't worry about memorizing this like right off the bat. This is just, it's something you can come back to later. So coverage, run. This is just how coverage works. So coverage, run, and then what we're going to do is pass it the file that we want to run. So in this case, it's going to be tests. So it's going to execute, and notice we get this new thing here, dot coverage. We haven't talked about it yet, but dot coverage is actually a SQLite database. So it's a database that's a bunch of files, basically. And we can take a look at that later. So that's not so important, but so coverage runs and it collects a whole bunch of data while it runs, and it saves that data in this text kind of file-based, very lightweight file database. Okay, so we've collected the information, but it's not really, we can't use it. So there's another step we have to go through. So there are a couple different ways that coverage has to show you the results that it's collected. I think the easiest thing to see that you can go coverage HTML. So once you run coverage, run, and then whatever your file is, you run coverage.html, and it will take all the data that it collects in this database and then generate an HTML document. So we have a folder here now called HTML coverage. You can go in here and the index.html. This is kind of the convention for an entry point into the HTML file or web application. So I'm gonna, basically what we want to do is open this index.html file, and we can open it locally. There's a few ways to do it. I'm going to use open with live server. This is an extension that I have installed that I would recommend, but certainly no obligation. So I'm going to open this with live server. You could just open it in your browser. So we get this display. So you can see one that here's what it's actually tested. So it's tested car and it's tested tests, which maybe we don't want, but it's there. We can exclude that, but we don't go. I don't want to go into all of the command line options here, but you can check out the documentation. So we have car. Notice that it didn't pick up on our mechanic car.py. We could also fix that with some command line adjustments, argument adjustments, but let's go ahead and look at, we're going to click on car.py, and this gives us a nice visualization of our code and what ran and what didn't. So all the stuff in green ran, and here's what didn't run. So just at a glance, I know if I'm writing unit tests and I see this, I can say, well, I'm not done yet. I need to test take damage. So it's just kind of at a glance. Again, it's not going to solve all of your testing problems. You can certainly write bad tests and get full coverage, but this is kind of an obvious place to look. So let's go ahead and let's write a test for take damage. And, Cindy N.
Yes, what are we doing now again?
We're going to write a test. So we've been writing unit tests, and we thought maybe we were done, but we're not sure. So we double checked with this coverage tool, and we saw that here's some code
Okay,
that hasn't been run yet. So we need to test.
defects, yeah. So, def test damage.
Okay.
Self, yeah. And then do with patch the car.random.
Okay. So why are we patching?
Because we want to get wear and tear is going to be called.
Right. Okay.
In self.wear and tear. And then fake rand range dot return value equals 0.5. Is that between 0 and 1?
It's but it's only integer.
Oh, it's only ints.
It's going to be 0 or 1. Yeah.
Okay. 1.
Okay.
And then we need a car.
Okay.
So car1 equals.
So again, we would want to be thinking about refactoring into test fixtures, but we're just gonna keep this simple for now.
And then can we say if fake rand range?
So this function is going to run this code directly, but it's basically gonna intercept the call to rand range, and it's gonna just return 1. So wear and tear is gonna return 1. So this is gonna be 1.
Self.assert equals.
Okay.
Assert, I think there's an assert array equal, isn't there? Or assert list equals.
Yeah, I mean, so you can compare, but why? So can you tell me what you're thinking?
Oh, I'm thinking to check defects and see if it equals brakes, tires, and engine.
So here we're just, I mean, this is just an assignment in the code. So here are all the possible defects. Again, if this were real code, you probably want to put this somewhere else, but so this is just a list of possible defects. And then what are we doing on this line, on line 16?
It's choosing one defect.
Yeah. So the result of calling this function and taking
Randomly.
path,
yeah.
it's going to choose one of these three.
So we need another patch.
Okay.
For choice.
Okay. So you can embed with statements.
Okay, fake choice dot return value equals breaks.
All right.
And then we can do car1 dot defect equals self dot assert equal, and take that out of the width, right? Or no? Yeah. No, I'm sorry, keep it there.
Yeah.
Assert equal car1 dot defect comma breaks.
Okay, cool. So let's run our test and see if this works. Okay, so that failed. Car1 dot defect will break. So let's take
I think it's on 23, car.choice. Should that be defect?
It should be plural, right? Defect should be plural.
You never called take damage, so you technically don't have any test coverage on take damage because it was never called. So it never set the instance attribute to defect, right? So it was initialized on line 7 to defect is none, and it was never changed because take damage was never called inside your unit test. I don't know if that makes sense, or maybe I said that too fast, but
yeah, so we didn't actually call this the function that we're testing, right?
Right.
So we created an instance, and then we've patched, at this point, we've patched both choice and rand range. That's going to cover this, and it's going to cover this. So now we can call take damage.
Car1 dot take damage.
Yeah. So once we call take damage, now this should run, and this should pass, and this should choose breaks, and self.defect should be breaks at this point. So now that should work. All right, so that passes our test. Now let's recheck our coverage to see where we're at. So coverage run test.py, coverage HTML. And because I already have this running with live server, it will update live. Oops. So now I have 92% coverage. So we've called this function, and we're taking this branch. So we've exercised this code, but we haven't exercised this.
So we just need to call the fake range dot return value equals 0, and then assert that it's equal to none. Right or no?
Yeah. So we could put that. Well, let's go ahead and let's do. Jared, can you write me another? So let's change the name of this to test damage taken something, and we'll do test. So we want to execute. We want to make sure we're executing line 18.
Okay, so with patch car.rand range as fake rand range, and we want it equal to 0 instead of 1.
So why are we doing that?
So that it'll hit the bottom else statement.
But why are we patching rand range?
Oh, because it won't be the same every time unless we pass in a set value.
Okay.
It'll be random.
Right, that return value equals 0.
And then create the car1 equals car Mazda. And then call take damage. Car1 dot take damage. And then self dot assert is none for car1 dot defect.
All right, let's try running this. Okay, so that passes. Let's rerun our coverage and regenerate the HTML report. And now we have 100% coverage here. So this doesn't update. So again, there's a lot of other kind of other modifications, but that's the basic idea.
Jed, if you were running random or choice within the car class somewhere else, would those patches affect those other places as well?
It shouldn't. So if there were another class, so for one, because we're using this context, it's going to change it only within this block, and then it'll change it back.
I was questioning that patch at first, but now I realize why it works. And it's hold on, I think I can annotate. Yes, I can. So when I was questioning it, I was thinking you were talking to the car class, but you're not at all. It works because you're not talking to the car class. Patch takes a module, so you're talking to the module, and then you're talking to rand range. So you're actually just bypassing the entire class. So you're saying I want to patch the built-in rand range and force the return value of anytime that's ever called. I want to force this to be 0 as the return value. And so then you're basically impacting this call to always, it's always going to be 0 when you force it right there. Sorry, I'm drawing all over the screen now.
It almost looked like a car. I'm sorry.
What was that?
I said it almost looked like a car.
And then actually I wanted to point one more thing out, because this is more of like a logic error that your test is not going to, because of, what line is it? Because of the random range being forced, and because your test doesn't actually test this, this will always be 0 all the time, no matter what, because the second argument is exclusive. So that would have to be 2 for that to ever roll a 1 in the randomness.
I think for rand range, the second argument is actually inclusive. So
yeah, I thought so too, and I just ran. I just ran it through a thing. I can show you just to show you I'm not crazy, but I thought it too, and then I ran a test on it, and then it comes out 0 every single time if you have it. Yeah, you're doing exactly what I did, and then you just rerun it a bunch of times. Should be 0 every time.
I swear the documentation.
There's one called rand int. I think that one might do it because I think that one's inclusive on both sides.
Yeah, rand int is inclusive.
Okay, sorry about that.
And if you have time, can I show you how to avoid that second patch that you're doing?
Sure.
Possibly. I need to find one assert statement that I don't know if it has or not. I could get it most of the way there, but I don't know yet what I want to put for the assertion. But so if you you want to, would you copy paste that just so we don't get rid of it?
Yeah.
Whoever did that. No, the whole test. Or yeah, you could do that too, I guess. I was just gonna rewrite the. Yep, so we can do exactly what you did kind of within the patch, right? So all we have to do is call that instance method, take damage. And because that method is an instance method, and because it mutates the attribute we're looking at, you can just call it and then do an assertion against car1's defect if you wanted to. And if you want to test the randomness, then all you have to do is assert that that value is in some kind of given range.
Right. Yeah.
But I don't know off the top of my head if there is a self-assert in. Oh, there is actually. Oh, cool. Yep, there is. I thought there was, and I kept looking for it. So self-assert in, and then all you do is say car1.defect as your value, and then the thing that you want to assert it's in, you actually have to include. Oh yeah. No, that's fine. I was gonna say none, but we're not testing both sides. We're testing just the true side of the if statement. Yep, that's another way to do it too if you want to avoid that second patch. Anyways, that's all. I'll be quiet now.
Cool. So yeah, so there's a lot of different possible variations, and again, patch. It's all just kind of mocks, so you could potentially do this just using mocks directly, but I think this is a convenient way of doing it.
Yeah, I actually really like line 24 because I like doing it that way because now you're not forcing a value. You're saying literally, I want you to run your logic and I'm going to test you against all the possibilities that you should have been. And that feels more like a test rather than facing. The second patch kind of feels like I'm forcing it to be that, and then I'm checking it against that, and then makes me question how thorough that test is.
Yeah, so there's I think a couple arguments you could make. One is that after this, you would probably want to make this more robust is fake rand range and make sure that it was actually called that assert called or called once or some variety of that. So yeah, the issue is that, of course, with stuff like this, if you're kind of testing the Python implementation in some sense. So either you can kind of override this and then actually test to make sure that your code calls this, or yeah, I mean, I'm not sure if there's a clear difference. Yeah, I don't know. I'll change this to 2. Well, are there any questions?
I'm still confused about, like for example, on line 25. So it's taking car in that line is the file car, not the class car. Is that right?
Yeah.
So it's taking any time that we run random range. Wait. Anytime that we run random range, I guess, yeah, on line 20, not 25, on line 20, anytime we run random range in the file car or module car, it's going to give us this return value of 1. So if we had run random range on another place, and it was part of the test, both of those random ranges would be 1. Is that right? Hypothetically, like if we had, if we used the method random or the, if we used random range more than once in, where are we at? I guess in wear and tear, for example, if you like random ranged it and then did something else with the same, yeah. Right, exactly. So both of those would return 1 if we were writing some kind of anything that had both of those. Is that right?
Yeah.
Okay. Because we never, in the code, we never specify what we're using it on. It's just that that's what's within the test.
Patches kind of wrapping itself around range. Range.
Right.
Anyways,
Yeah.
so yeah, when you basically when you say this line, it's watching that. It's like, I'm going to be a wrapper around this. Anytime you ever call that thing, which is being called here, like you're actually invoking the calls.
Right. And the only way it's limited is because our test on, everything that's after line 19 is just within.
Yeah. So somewhere in here, right, we have to, somebody indirectly called rand range, like somebody made this happen, right? So take damage actually calls wear and tear actually calls all of those, and now it's getting messy really fast.
Right.
But yeah, you can see that happening, right? Like you're physically calling. When this gets called, you actually invoke that rand range twice, and because rand range is being watched by patch, it's saying I will always make these return values because it's within the context manager, this block. Everything inside this block, the moment you exit this block, it doesn't happen anymore. But while it's inside this block, it's always going to be 1. And then so for this one that's down here, it's always going to be 0 when that test runs. And then when it exits the context manager meaning the with statement right here, when it exits that, it doesn't do it anymore. It doesn't get applied anymore. But yeah,
that makes sense. Yeah, I was just trying to figure out how it was limited to those places, but that makes sense if it's just because of the content manager, the with statement. Thank you.
Are you ever going to need parameters inside the function that you're patching?
So let me just real quick, let me just kind of show an example of what's happening. So def do something. Print on this. If I actually do print here, it's gonna loop forever. So let me do. I'll just return. Yeah, so this is actually not going to work because it's going to do infinite loop. That's a good example. Anyway, so if I call, so the point is I could call print here. And print is now not going to be calling the built-in Python print. It's going to be calling my print. I think this will just blow up. But yeah. So there's an issue there, but so this print is now going to call this one, which is not going to refer, because it has to do with the way lookups happen. So it's gonna check the local environment first before it looks in the built-ins. So it's kind of like when you have a class and you have a subclass and you override a method. So the method exists on the parent class and also exists on the child class. It's gonna look up the method in the child class first, and it's gonna find it. Then it's not gonna also check the parent. So it probably makes more sense to do than that. So let me just do that. me rename this to X so it's not unduly confusing. So now I'll create an instance of B. Self. Oops. So I call B, right? And then B's printer is called, right? So if this doesn't exist, then the A's printer is going to get called. So if you intercept, so when I call B's printer, it's going to check in B first. Do I have printer? If not, then I'm going to go up. I'm going to start looking elsewhere, anywhere else I can. And something like, and that includes built-ins. So it'll start locally, it'll gradually expand its search wider and wider, and then eventually look in built-ins. And if it gets intercepted before then it will call your thing first. So I don't know if that's clear or less clear.
Yeah, that's helpful.
Sorry, Cindy, did you have a question?
Yes. So I was wondering, like, is there ever a case when you would pass arguments to the patch place, or it doesn't matter because you're always returning, you're always telling it what to return, so the arguments really don't matter?
Yeah, I don't know if there would be a case where you might want to do that. I don't know if you would want to pass arguments. I don't know. Chris, can you think of an instance?
I mean, patches, it's just like this fake object that kind of imitates whatever you told it to watch. So in this case, like line 20 is watching random range is a function from a module. That's where it came from. It's basically just like a function object. And then so patch is like imitating everything that rand range is, and it adds some like extra meta data on top of it. So you can like assert it received arguments, stuff like that. It's a decorator. You briefly went over decorators. Patch is very much a decorator. It applies a function around whatever you told it to watch. So random range is a function. Patch is decorating that function with another function, and or something that's like a callable. It could be a class. I actually don't know if it's a class or a function. I just know that it's some kind of callable object like that. But at the end of the day, what you get is
it's
patch,
all
yeah.
the object.
Yeah, so patch will basically just watch the thing that you gave it, which it knows it's going to be an object of some kind in Python, some kind of built-in object of Python, because everything in Python is an object. So it knows that much. And it's like, all right, if the thing that I'm watching is a function, I know that it can return something, so I can force a return value from it. I can basically watch it as it gets called, but I basically can impact the return value that comes out of it. It's just under the hood. It's like containing your object and watching everything it does, but not letting it escape out either end. You're always talking to the faked object. So the fake object is returning you what it knows to return back. It's really weird thing to think about, but whatever you pass, whatever you're telling it to watch, like random range, whatever arguments you feed when you call random range, the fake patch object, it can see anything that you passed it, because all it did was forward it on. And if you remember decorators, all you did was forward on those arguments into the nested function that you had, right? There's probably a better way to like demonstrate this, but I don't have any examples right now. I could make one if you're really, really curious. I could probably like make some kind of visual example of what might be happening. I don't know if that helps, right? Like fake object is just, it's isolate, it's like wrapped around and containing the thing that you passed it. So random range is a function and the patch is waiting for you to call that function. And the moment you call that function, you're still effectively calling that original function, but the decorator that wraps around it is actually like is what you're really talking to. You're like, it's like accepting all arguments. So when you pass an argument to rand range, when it's been patched, you're actually passing those arguments to the patched object and it's forwarding it to rand range, if that makes sense. It's kind of like, yeah, I don't know how to explain it better than that. Sorry. Hopefully that makes sense, or it's making something.
So can a patch also mock your own functions or only built-in functions?
It can mock your own functions. Yeah, so I'm not sure there's a use case for passing in parameters because yeah, you're not actually going to be passing in parameters to the actual rand range in any case.
You could check, you could do an assertion of if rand range received specific arguments, right? Like you could do an assertion that rand range received 0 and 2, or it received 1 and 9 and then 0 and 2.
Yeah, so here we're doing that. So that's kind of checking what your code is doing, but from the test, it would be, I don't know that there would be any point to passing the fake rand range in an argument.
So the fake rand range is it will be past the arguments that are in our code, right? So
yeah, exactly.
The decorator that Chris was talking about with patch, it receives the inputs, forwards those inputs to our function. Then it receives the outputs from that function. And then, depending on what we do with it, it then outputs that back to us. Something like that.
Yeah, so it won't actually call the real function. So like the actual Python rand range is not going to get called during this test.
But it would still show up on the coverage file, right?
Yeah. Because, I mean, this line will get executed, but this rand range will just be a different rand range.
It's just getting caught, yeah.
Yeah.
So if we didn't force a return value, would it return none instead of returning what a normal rand range would return?
Yeah, by default, let's see. So you call it, yeah, I'm not sure what a mock object called a method will return by default.
I think the only thing you would actually break is take damage, because take damage calls wear and tear. And so if you got rid of wear and tear's return value, then line 14 it won't get a 0 or a 1. And so it will get a none. So you'll say if none, right? Like on line 14 for car. So if that's what you're talking, is that what you're talking about, Greg? Like get rid of line 11's return, but just like calling rand range, but not returning it. Is that what you're talking about?
Yeah. So my original thought was that the rand range, the original one, was kind of being wrapped by the patch, and that if we didn't modify it at all with like fake rand range return value, then it would just call the original. But
the mock will still work. So the mock will still watch that call, that execution of rand range happen on line 11, even if it has a return or not. It will still happen because that return belongs to wear and tear, not to random range. Random range has its own return value that it runs.
Yeah, so I was just wondering if it would still run the original rand range if we didn't modify the return value.
Yeah, so the mock itself will still work, but line 14, when you're testing the take damage method, it relies on that return value of wear and tear. So that would probably break because, yep.
Yeah, so this is what happens when you call the mock method without specifying a return value. It just returns the mock object.
And
Yeah,
that's,
so yeah, that answers my question. The original rand range isn't run at all.
Yeah, right. Okay, this is a little confusing. I think that it seems like, so the point of this lesson was to show coverage. That seems to be relatively clear. The patch stuff, again, we've talked about before, but it is weird. So more exposure, that was good.
listen, if y'all are picking up the patch stuff this early on, it's a good thing. If this is starting to make sense, I can tell you right now that I did not learn patch this early. It took a while for me to learn patch. I didn't even understand what was going on in there at all. So if you're picking up some of it, that's pretty good for testing. You at least know how to do that. So
Yeah, you guys should know that I'm throwing in extra stuff because I see that you guys are chugging along nicely. So yeah, this is not really a part of the official curriculum.
Yeah. So it's similar to if we like had a naming conflict and like just overwrote the original rand range rather than using like a decorator or something.
Yeah, so we're over it. So it's just like you have a class and a subclass, and if I call printer, like that example that I just had, I don't know if I can, right? So if I call class B's printer, I mean class A's printer still exists, but it's not getting called, right? So I'm not like deleting this or anything. It's just that it's going to find this first, and once it finds it, it's going to stop looking. So it's the same thing here. It's basically imposing itself on the namespace, and because built-in lookups happen after local lookups, it's basically just like covering it in the same way that it's overriding it.
So Chad, when we're building our tests or writing our tests, coverage is helping the, it's not, and what is the, not NPM, but coverage itself, the
Yeah.
package is helping us by just saying everything's been run. So after we know that everything turns green and everything's been run, do you have any other like checklist type of things? Like what else do we go through besides just seeing that every line has been run? Do you have any other things?
I mean, yeah, so there's definitely, I mean, you could run like profilers, but I would not start worrying about things like that. So this is, this is already extra. So we're already in like bonus territory. So if you're writing unit tests, this is just a tool to kind of guide you into, what test should I write next? Or am I
This
done?
is a pretty thorough start, is what you're saying.
Yeah.
yeah, this is a really good start, but just know that you can write tests that are you can trick coverage. The purpose isn't to trick coverage into like faking that you checked line 14 properly. Coverage is like, we ran take damage method. We did the truthy side of the if statement, but your test could run that far and then test something that's completely, that's not something that's the thing that you should test. I could make any assertions I want at that point, and then coverage will think that I tested those lines. So there is like a limit to what this is a way to like tell if you missed like your branching code, right? Like, oh, I forgot to test the else side. And then it's more or less up to you, right? It's more up to you how in depth you want to test each one of those branches. Like, I want to test all of the possibilities of that list that defects could be. Like, every time I run this test, randomness is the hardest thing to test because it's random. So you have to write your test in a way that can truly test randomness every single time you run that test. And you want to, maybe that's like the whole purpose of this class is to like do that thing. And you just want to be sure that it's testing what it should ideally be tested, like thinking about how you're using it versus what it does, and then how you should test that, like what assertion you should properly make. Coverage doesn't tell you that you tested it the right way. It just tells you that it ran. your test ran across those lines. And then whether you ran across 100% of the lines in that file or not. But that's
I'm thinking, for an example of that, it could be if you're trying to get a true and a false or a false, you're trying to test for a Boolean, and you test for a 0 and a 1, but you don't test for something else like a none or a non-Boolean, then you might miss something, even though you've run all the code.
Yeah, or like making assertions about like logic errors, right? How we had random range where it was exclusive, right? We were forcing the value to be 1 every time in the test, but we weren't actually, if our job was to test, hold on, let me backstep real quick. You should only ever have to test your code. So you should never have to test Python's implementation, right? So if there's a built-in in Python, you shouldn't have to assert that a list is a list, right? Like that doesn't make sense. You don't have to assert that true is true because that's true.
True is not working, then there's a problem.
Yeah. If true isn't true, then you have a much bigger problem going on with your version of Python. But you don't have to test the implementation of what Python already has because it's their job to maintain the tests for what they wrote. Your job is to test your class, the functionality of your class, what your class is supposed to do. So when take damage runs, if it's mutating the state of an object, like changing an attribute, self.deficit is changing, your job is to test that attribute changed when that function ran. And then like what impacted that change? Like these are the things that you should think about when you're writing a test. Like when I run this thing, what is supposed to change and did it change to the right thing basically testing your assertion. I'm asserting that this change took effect and changed to the correct thing. Or the else statement ran, and so the truth side didn't work, the false side ran, and now it should be none instead of one of those possibilities. But yeah, it takes time. It's actually really funny that test-driven development is pushed on people really early, but they don't know yet how to compose code yet. So you're like trying to write tests for code that you don't necessarily know how to write just yet. But it's good to try to do a side by side because I think you learn faster if you do it that way. Because I didn't learn it that way. I actually learned to write code first and I avoided tests at all costs. And then I had to do tests as a follow-up later. So I think it's actually better that you're learning tests much earlier on, even though you don't know how to necessarily write them yet. As you start getting better with your code, your tests will improve alongside it. As you'll start questioning yourself, like, is this test even necessary to write? I feel like I'm testing whether I can append to a list, which I'm basically testing the functionality that's built into Python, right? I'm testing if the item that I appended is in the list. That's not your code. That's Python's list code. So yeah, you don't have to do that, but just test that if you wrote a append method for car class for some reason, then yes, you want to test the append method of a car class, even if it has an offloaded append that it does with a list at the end of the day. So I'll stop there. There's a lot to talk about in there, but just know that you'll get better at it with more practice, and when you start questioning your own code and what you're testing, that's when you're learning some stuff there.
So Chris, you mentioned we should write code and test side by side. So what do you think about writing the test first and doing the code second?
No, that's what I'm saying is like when you're new, it's kind of hard to do that because you don't know how to make assertions about code you haven't written, because you don't know how to compose objects necessarily just yet. But once you do, it becomes easier because you're like, I know how I want to interact with an object. I know what instance methods I'm gonna call, right? I know how to interact with this object. Therefore, I should be able to like start out with my test and just interact with the object and then make assertions about my interactions with the object. But at first, when you're learning Python stuff, right? You don't know necessarily how to compose a class together and what instance methods are and how to interact with them just yet. So it makes it really hard to write those tests. That's kind of what I'm saying is like, your tests aren't going to be perfect at first, but as you grow with like objects in Python, how to write objects. Sorry, Chad, I don't mean to talk for this long. As you grow with objects and learn how to write instance methods and work with instance attributes, your tests are going to start improving. So it's good to have like knowing how to write a test is great. And then as your code improves, always go, always try to write unit tests because they're not going to be great at first, but they're going to keep getting better because as you learn more about the code, you're just going to get naturally better and you're going to start questioning things. And that's when you know that you're really like starting to learn. When you're questioning things, that's like an indicator that you're probably asking the right questions.
All right, cool. So I'll quickly go over the challenge for today. Again, so in the README, there's also, brief, very simple overview of inheritance, if you would like a reminder. Then we'll be doing school interface 2, which is building on what we did Saturday. So it should be pretty self-explanatory. We'll just be adding another couple features. So if you haven't done the first one yet, and yeah, if you haven't done the first one yet, then you can let me know and I can work on it with you and we can knock it out real quick.